Welcome to the deep dive. You send us the material, we dive in, and basically pull out the key insights so you can get up to speed fast.
And today, we're tackling some really big questions. Thought, intelligence, agency, consciousness, pretty deep stuff.
Yeah, definitely.
Yeah.
We got this YouTube transcript from a listener. It's a conversation with Joscha Bach, who's a cognitive scientist and AI researcher.
Right. The source is Joscha Bach, Why Your Thoughts Aren't Yours, from Machine Learning Street Talk. Really interesting channel.
So our mission today is to, unpack some of Bach's ideas. They're quite out there sometimes, but really thought-provoking.
Absolutely. We're talking about, like, what does it mean to be in charge of your own thoughts? Is reality kind of virtual? Where's AI actually going?
And this concept he calls cyber-animism, which sounds, well, intriguing. We want to pull out those key nuggets for you.
Yeah, things like why he thinks our conscious selves are, in a way, virtual. And his take on AI development's not just about skills.
And that animism idea, but viewed through the lens of software. Okay, so where do we start? The virtual self?
Let's do it. So this idea that consciousness is a virtual property, what he means is it behaves as if it exists in a solid way, but maybe it doesn't, not physically.
He uses that Minecraft analogy, right? Like the game world isn't physically there on your hard drive.
Exactly. It's just, electrical patterns, signals, making the computer behave as if Minecraft exists. It creates the causal structure of the game.
So applying that to us, our brains are the hardware, and the person, the sense of me, is like the software, the patterns of activation.
Kind of. It's the behavior produced by those patterns. There isn't a literal little person inside the skull, just these complex interactions that act like a person.
And he ties realness to how well something is implemented. So Minecraft is real in the sense that it has effects because the code is running.
Precisely. And our mental states, our consciousness, are real in that same way they're implemented by brain activity, and they have real consequences for our actions.
So if our sense of self is virtual, what does that mean for, like, free will, agency? Are we just running a program?
Well, that's the big question, isn't it? Bach argues that even virtual things, like software, can have causal power. Think about an algorithm. Trading stocks, it's virtual, but its actions have very real financial consequences. Our thoughts, our consciousness, direct our actions.
Okay, that makes sense. It's not physically tangible, but it does stuff.
Exactly. Let's shift gears a bit to artificial general intelligence, AGI. Bach mentioned he's been thinking AGI is coming for a long time, since he was young.
Right, and there's obviously a ton of hype about it now. But he seems a bit cautious about timelines and even what we mean by AGI.
Yeah, it's interesting how our picture of AGI has changed. Maybe we used to think of the Star Trek computer.
Yeah.
Ask it anything, it knows.
And now we have large language models that can talk, but they also hallucinate or fail at things that seem easy for us.
Right. They perform impressively in areas where we're novices, maybe, but below human competence in areas where we're experts. It's a weird mix.
Which leads him to question if intelligence is really about task performance, or maybe more about learning new skills.
Exactly. Skill acquisition. How efficiently can a system learn something new? That might be a better measure than just checking if it passes a human test.
He's not a fan of using human IQ tests for AI, is he?
No, because they're based on human cognition. He suggests we should look at performance before and after learning, factoring in the data and computation needed.
So what's his actual definition of AGI then?
He puts it as the ability to make any mathematically obtainable model given the resources. So if a model can be built from the data, an AGI should be able to find it.
Which is different from just predicting the next word like current language models mostly do.
Very different. Predicting text is one thing, but proving something like the Riemann hypothesis requires constructing a novel solution, not just pattern matching existing text online.
But he does see potential in self-play for getting beyond that.
Definitely. Look at AlphaGo learning Go, or AI learning chess, or even programming by competing against itself. If we can frame problems in a way that allows for this kind of self-improvement cycle, that could be a path forward.
Okay, let's talk about agency. He makes this distinction: intelligence is the tool, agency is how you use it.
Right. Agency is about controlling the future, using models to predict and influence what happens next.
Not just reacting to the present, like his thermostat example.
Exactly. A thermostat just keeps the current temperature steady. An agent tries to model the future state. If I turn on the heat now, it will be warm enough in an hour. That ability to model the future is where preferences, goals, and knowledge seem to emerge from.
And he mentioned a key step is discovering yourself. What's that about?
It's about becoming aware of your own model-making process. Understanding your own biases, your learning limitations, how your own mind works. It's like being able to debug your own mental source code. That self-awareness is crucial for higher agency.
Interesting. This connects to his ideas about virtual patterns and emergence. He seems a bit wary of that term, emergence.
Yeah, he finds it a bit hand-wavy sometimes. Like it implies magic that complex things just poof into existence.
His analogy is software and hardware again, right? We don't think it's magic that Windows runs on silicon.
Exactly. So why treat mental states arising from brain states as magical emergence? He prefers thinking about self-organizing virtual patterns that have real causal effects. Like money, it's a pattern, an agreement, but it drives economies.
Okay, so maybe weak emergence, like it's some surprising complexity, but not fundamentally unexplainable.
Something like that. But he warns against using emergence as a label that stops us from actually figuring out the mechanisms. He gave that example of drawing a line on an old Commodore 64 computationally complex underneath versus how a mathematician thinks about a line abstractly.
Our brains simplify things.
Hugely. He calls the brain a self-organizing game engine, doing inverse rendering, trying to figure out the hidden causes behind the sensory data it receives.
And he talks about two parts of the mind, a generator and an interpreter.
Yeah, sort of an outer mind, the world model, the generator, and then an inner self model, the interpreter. And these two systems are both learning, adapting, but they might not always agree.
Which could explain internal conflict.
Possibly. Our basic biological needs get translated into drives or urges. The self model then interprets these within its world model, creating our perceived goals or purposes. Emotions, in this view, are like a score, feedback for the self-model character in the game.
And meditation might let you observe this. See the urges as representations.
That's the idea. Realizing they're not direct commands, but signals within the system. It ties back to agency being about managing that future state, and the self is part of the environment you're trying to manage.
Which brings us to cyber animism. This sounds pretty unique.
It is. He starts by saying it's hard to understand new concepts if you just try to map them onto what you already believe.
Right. So his take on animism isn't the usual everything has a soul idea.
No. He suspects that maybe when ancient cultures talked about things being alive or conscious, they meant something more like dynamic, self-organizing, self-sustaining.
Like software.
Yeah.
Or self-maintaining system autopoiesis.
Exactly. He thinks our modern concepts sometimes lack the words for these kinds of causal patterns. We get stuck arguing about free will because we treat will like a physical thing, not a type of representation or process.
So a spirit in his cyber animism is like a self-executing piece of software.
Sort of. A specific class of self-implementing software agent that can run on a suitable substrate, like a brain, and perceive itself. It's a physicalist view, not supernatural. Evolution then becomes competition between these software agents using biological hardware.
Okay, that's a lot to process. What about consciousness itself? He calls it second-order perception.
Right. He notes it's often avoided in science, maybe because it's hard to define or measure objectively, but subjective experience is undeniable.
And the key features for him are experiencing and nowness.
Yeah. Experiencing isn't just having the data like a camera sensor. It's the system registering something, a perception of perception happening right now.
Like a meta-perception.
Kind of. And nowness is this feeling that it's always happening now. He describes consciousness as this dynamic bubble of nowness in our mental engine, a region kept free of contradictions, maybe related to integrated information theory's idea of integration.
And Descartes' I think, therefore I am, fits in here.
As a kind of anchor, yeah. The self-observation concerns the process, the nowness.
So where do the software agents fit with this consciousness?
He sees consciousness as a property of the host system, the brain. The software agents operate within that conscious host. The idea of the host itself is a concept the software forms about its substrate.
Is he sympathetic to panpsychism, the idea that consciousness is everywhere and everything?
Not really. He finds it hard to formalize and doesn't see what it explains. Why would a photon or a rock need complex representations or agency?
He thinks consciousness arises in complex systems where it's actually useful.
Yes, systems complex enough to benefit from that kind of self-organizing awareness, and which have the evolutionary or developmental means to create it. He contrasts, like, the potential complexity in Jupiter's Great Red Spot versus a single inert rock.
Got it. Okay, another key concept, coherence.
Right. Coherence is when a system acts as if it has a single goal or function. It's about minimizing internal conflict, constraint violations.
We see it in personal development, integrating different parts of ourselves. or in teams working together.
Exactly. Relationships, societies, they function better with coherence. The world seems messy because it's full of partially coherent systems, and our consciousness is often busy trying to smooth out the inconsistencies we perceive, like a conductor trying to get the orchestra in sync.
And this applies to collective agents too, like groups.
Yeah, most complex agents are collectives, families, companies, nations. Coherence at one level enables agency at a higher level.
What about Gaia? The Earth is an agent.
He thinks it probably exists to some degree, a collective system regulating life, but likely a very, very incoherent one compared to, say, a person or even an ant colony.
And conflict arises from competing agents. How do you get coherence then?
Often through shared identity or purpose. When individual agents see themselves as part of something larger and more important, they might subordinate their goals for the group's coherence. A shared sacred value, maybe?
Which leads into AI alignment. He questions if some alignment approaches are coherent.
Yeah, he frames ethics in terms of shared purpose and collective agency. For him, current AI are mostly tools, not agents needing ethical alignment in that deep sense. We need control, yes, but agentic AI would need shared purposes with us.
He calls current LLM outputs deep fakes of agents.
Yeah, because they mimic agency as a side effect of predicting text, but don't necessarily have genuine goals or self-awareness in the way we do.
Okay, let's switch to the tech side. He works with liquid AI, liquid neural networks. What's different there?
Well, he argues standard neural nets are quite different from biological neurons. Liquid networks aim to be more dynamic, efficient, less memory, cheaper training, faster inference, and potentially better at continuous learning because their structure isn't fixed in the same way.
And his view on the AI startup scene.
He sees most building apps on top of the big foundation models from a few key players. It's tough for those building the big models because of the huge sunk costs, train a massive model, and then a slightly better one appears.
He values open source, though.
Big time. Things like Stable Diffusion create ecosystems. He even sees accidental releases, like maybe Meta's Llama models, as potentially beneficial historical accidents that spur innovation.
What about the future of LLMs? Is it just scaling, or do we need new ideas?
He acknowledges the scaling hypothesis that just making them bigger might be enough, but he respects people like Francois Chalet who make bold, falsifiable predictions that challenge that, like betting against scaling alone, solving certain benchmark problems. He thinks those challenges are valuable.
He sees bottlenecks, though. Training costs, data needs.
For sure. He talks about needing smaller, efficient inference engines, maybe like a smart 12-year-old base model you can quickly train on specifics, and maybe moving beyond text to represent thoughts more directly, like in a canonical conceptual language, an epistemological engine.
That sounds ambitious.
Yeah, he's optimistic about AI solving problems, but very uncertain on timelines for human-level AGI or huge breakthroughs.
Okay, last big area. Safety, regulation, freedom. There are obviously concerns. People like Gary Marcus raise alarms. How does Bach see it?
His view seems to be that AI is fundamentally a problem-solving technology. So the answer to bad AI is better good AI. He's also very focused on freedom of thought and speech, drawing on his background growing up in East Germany.
So he worries about control.
Yeah, control of information by governments or powerful entities. He distinguishes between flawed platform design, like on social media, and the core principle of free expression.
So regulation needs to be careful.
Theory. Balance innovation against harms like bias or privacy, but avoid stifling progress or regulatory capture where rules benefit incumbents. He uses Uber as an example, disruptive, controversial, but fundamentally changed transport.
What about things like copyright and AI-generated content?
Huge complexities there. Balancing creator rights with the public good of easily accessible information and tools. It's a tricky line to walk. The whole Elon Musk rock thing highlights the moderation challenges too.
His main point seems to be defending the freedom to think, imagine, and share ideas.
I think that's a core theme, yeah. Resisting attempts to control the infosphere too tightly.
Okay, so wrapping up this deep dive into Joscha Bach, we've covered a lot. The virtual self, the nuances of AGI, cyber animism, coherence, AI tech, safety.
Definitely some mind-bending ideas in there. Hopefully, listening to this gives you a good handle on his perspective, a shortcut to understanding these complex topics.
Yeah, lots of those aha, or maybe, wait, what, moments. So here's a final thought for you to chew on based on all this. If our conscious selves are, in some sense, virtual patterns, as Bach suggests, how does that change how you think about your own agency, your own reality?
And what does it imply for the future, for how we relate to AI and how we decide to guide or regulate these incredibly powerful emerging technologies?
Lots to think about. We definitely encourage you to check out the original source if this sparked your curiosity.